My name is Jocelyn.
And my name is Stephanie.
And we are both students of Dove Science Academy. Presenting the demonstration itself, let's talk about the scientist who helped center the concept of freefall. Born in 384 BC, Aristotle quickly became an accomplished scientist, philosopher, and physicist. He created many theories, proverbs, and inspired plenty of scientific innovation. What we will be focusing on today, however, is his thoughts and theories about freefall. Under his theory, he believed that different material acted according to their nature. For example, if his theory were to be true, a rock will fall because it's made out of Earth's elements, so its natural tendency would be to be with other material that is similar to it. In contrast, some will rise up because it's more closely related to the air elements. Among the conclusions of Aristotle's theory is that objects with different weights will fall with different rates, with heavier objects falling faster than lighter ones. Back in the day, this theory was widely accepted and the first concrete idea about freefall.
Fast forward to a couple centuries later, Galileo was born. He was also a renowned philosopher, scientist, and revolutionized the scientific world. He sought out to disprove many theories, especially Aristotle's. Eventually, he became the first scientist to disprove Aristotle's theory of freefall. To reach his conclusion, Galileo performed countless experiments that contradicted Aristotle's theory, including his famous Leaning Tower of Pisa experiment. After performing said experiments, he reached the conclusion that in the absence of air resistance, all objects fall on the same constant acceleration, g equals 9.8 meters squared. This acceleration is called the acceleration of gravity. This acceleration is always pointing downward, no matter if the object is moving up or down.
To test this out ourselves, we devised a simple action video demonstrating freefall. The materials we used in order to test the philosopher's theories are as follows: a piece of foam, a coin, a vacuum pump, and a coin feather tube. For the first demonstration, we placed the foam and the coin into the tube and flipped vertically as quickly as possible. As it can be seen, the coin falls much faster than the piece of foam. In the second demo, the same process was repeated. However, in this version, the tube was connected to the vacuum pump, creating a vacuum space. As demonstrated, the coin and the foam landed at about the same time.
This project demonstrates that while at first Aristotle's theory may seem to be the correct one, when proper conditions are present, Galileo's theory was actually correct. As mentioned before, Galileo's beliefs are considered to be true to this day. Eventually, his theory of motion was expanded by Newton and became the basis of the first law of motion.
In our ELA component, the journal is about each week of us doing this project, from week 1, which was choosing a project and creating an email, to our most recent week, which was creating this very video. For the SS component, we discussed the historical connections between Galileo and Aristotle's theories. It also mentions the different historical events that happened thanks to freefall theories.
As this video draws to an end, Galileo and Aristotle greatly influenced the concept of freefall. Although Aristotle's theory was incorrect, Galileo would not have been inspired to create his own theory of freefall without it.